Hello everyone, welcome back to my channel. Don't forget to like, subscribe and share. We're still on our model, it's a model about the recommendation to a customer to purchase the best used car using machine learning. So we're going to, it's a model designed with aid of machine learning. This time around, I designed a model that's well analyzed. It has clean data and a machine learning pipeline that has already split data. The data is split, trained, and tested. So we're going to I have a notebook where I'm going to share a link in the description of this video, just in case you need to know how this came about. You need to know how the data analysis, the code behind the data analysis, you will have to check the notebook. I used to Colab. I'll provide the link so that you get to know a lot more about this. So we're going to begin with the data analysis. Data analysis, it's just used to analyze the data using visual techniques, like how you see, you're able to see what your database, what your data set has. You're able to see that this is the head, which has only 5 data points. You can visualize the tail, you can visualize a lot of different things. And an expert is data cleaning. Data cleaning is the process of fixing or removing incorrect, corrupted, incorrectly formatted, duplicate, or incomplete data. So when you execute this command, this is a last command with the data cleaning processes, and then you don't get any output, that means your data is already clean. So at the end of data cleaning, the data set showed there is no duplicate data since it was already clean without the empty data. And our next part is the heat map sample. When you to get the heat map sample, for example, you're done with the data cleaning, analyzing, you're able to do a lot of different things. You're able to get heat maps, plot boxes, a lot of different things when you're done analyzing and cleaning your data. A heat map is a data visualization technique that shows magnitude of a phenomenon as a color in 2 dimensions. So this is the sample of a heat map. And our next part is the correlation matrix. A correlation matrix is a table containing correlation coefficients between variables. So you're able to see that this is used to summarize data. And the key components we have the magnitude and the sign. This is the sign. You're able to see positive, negative, you're able to see a lot of different things. And then our next part are the box plots. All this, to know how I generated the box plot, you can check the link and then visit the notebook I generated. So box plots are used to measure on how well the distributed and how well data is distributed in a data set, and then it's divided into 3 quartiles. So you're able to have price, mile age, so it's divided into 3 parts. And then we have our feature independence plots, and then this is the sum of our feature independence plots. I'll further explain this in my next video and then see how feature independent plots come about. We have our next part is the outlier plots. The outlier plots, these show the extreme values within a database. So you're able to see what's exceeded, tax, MPG, engine, you're able to see a lot of different things. And our next part is the illustration of the patterns of interest. So this is the illustration. I'll also further explain this in my next video. There is a code in the notebook. You can tap the link and then see. Patterns of illustration do exist in various scales in time and space. I'll further explain this. And our MPG is leading. And our next part is the trend in time and space. So you can see the time, hours. You can see different trends of different used cars, the tax, and a lot. And our next part is the machine learning pipeline, our second part that we had talked about. Our machine learning. So this is going to illustrate the machine learning pipeline for the project performing the following tasks, whereby we have to explore and clean the data which we already did, and then this is our final equation whereby we got no output, meaning that the data is clean, and then we have to split data into train, validation, and test sets. And this is our training data when we are done splitting. This is our validation data, 1600. This is our test data. And our next part is fitting a model of your choice. So here, the regression is defined as super machine learning technique. And then I use the nonlinear regression model. That's what I fitted in. And then this is the procedure. This is the nonlinear model graph. We also have the tuning of the hyperparameters. I tuned the hyperparameters and I used the GridSearch CV, and this was the outcome. This was the classification report. And our final part is the evaluation of the validation set. So we measure the model. To measure a model and know whether it's good enough, we use the method of train and set. Models are created to predict the outcomes of certain events. So when we train the data set, we got the accuracy of 0.962, and then when we tested the data, we got the accuracy of 0.9768, and our loss was 0.0723. This is what I had. I'll further explain the key points I've mentioned about in my next video. Thanks for watching. Don't forget to like, share, and subscribe.